In this video, I'm going to show you how to factor using the difference of squares strategy. Now your answer should look something like this: a plus b times a minus b. When we say difference of squares, first of all, what is a square? Well, if you square a number, for example, let's see, 1, 2, 3, 4, 5. Imagine if I squared each of these. Can you see that this would be 1, and this would be 4, and this would be 9, and this would be 16, and this would be 25. So these are all squares. They're perfect squares. So that's why you're going to see these types of numbers showing up. Like 49, that's 7 squared. Okay? But variables can be squares too. Obviously, if you have like x squared, that's a square. But even imagine that I had x to the third power squared. That would be x to the sixth power. So even x to the sixth power, any even power is going to be a square. Okay, so the general pattern works like this. If I have something of the form a squared minus b squared, okay, difference means subtraction, then this should factor as a plus b times a minus b. So let's see how that looks for a variety of problems. So when we look at problem number 1, okay, this is going to be x plus something and x minus something. Well, 100 is 10 times 10, right? It's 10 squared. So that's why it's going to be x plus 10, x minus 10. Okay, what about number 2, difference of squares? Well, 4 is 2 times 2. X to the sixth power is x to the third power times x to the third power. All right, when you multiply variables, you add the exponents, so that's why it makes sense. So this will be plus and minus, and 7 times 7 is 49. Okay, so this is our a plus b, a minus b pattern. Okay, now this one is not the difference of squares because 8 is not a perfect square. All right, 8 cannot be written as something squared. So the directions say 2 of them cannot be factored using difference of squares. So we're supposed to write not DOS. So that's what we're going to do, not difference of squares. Okay, but number 4 is difference of squares once again. All right, with variables, you're just going to do half. So this is going to be y to the fifth power times y to the fifth power, all right, plus 1 and minus 1, all right, because 1 times 1 is 1. Okay, this is the difference of squares. All right, they're both variables, so I'm just going to do half twice. I meant to put the x first, so let me grab my eraser. So this is going to be x to the sixth power times x to the sixth power, all right, plus and minus. And then half of this is 3, so y to the third power times y to the third power. Boom. A plus b, a minus b. This is not the difference of squares because this is supposed to be subtraction. All right, difference means subtraction, so it doesn't work for addition. But number 7 is the difference of squares. 16 is 4 times 4. X squared is x times x. And 81 is 9 times 9, so this will be plus 9 minus 9. Okay, how about number 8? 49 is 7 times 7. X to the fourth power is x squared times x squared. 36 is 6 times 6, so this will be plus 6y minus 6y. In a previous video, we learned how to factor by factoring out the GCF, or greatest common factor. So for the rest of these problems, some of them will be difference of squares, and some of them will be GCF, and some of them will be neither. So let's look at this problem number 9. So it does not fit the difference of squares pattern, but I do see that there is a common factor. So let's go ahead and check this, and now let's do it. Let's see, both terms have variables, so that means my GCF will have a variable in it. What's the smallest number of variables you see? So I have x to the 5th power x squared. The smallest amount is x squared, so that's how many I'm going to pull out. So I'm going to have x squared as part of my GCF for sure. Now look at the number part. What's the biggest number that goes into 6 and 12? Well, 6 itself. 6 goes into both of these. So this is my GCF. Okay, if I want to know what is going to go inside of my parentheses, I need to divide both of these by the GCF. So I need to divide by 6x squared. All right, and that will tell me what goes in the parentheses. So 12 divided by 6 is 2. X to the 5th power divided by x squared is x to the 3rd power. With variables, you subtract these. And then be careful. All of this cancels out, right? Right? 6 cancels out, x squared cancels out. But I don't put nothing. I put 1. All right? Because anything divided by itself is 1. So, you know, like 6 over 6 is 1. 6x squared over 6x squared is 1. So this would be the answer to number 9. Okay. This does not fit the difference of squares pattern either. But there is a common factor. There is a GCF. Both terms have variables. This one has 8 x's, this one has 2. What's the smaller amount I just said? 2. So that's how many x's I can pull out. So x squared will be part of my GCF. What about the numerical part? What's the biggest number that divides into 10 and 6? Well, 6 is divisible by 2 and 3 and 6. 3 and 6 do not go into 10. So 2 is the greatest common factor. So I need to divide both of these by 2x squared. And that will tell me what goes inside the parentheses. 10 divided by 2 is 5. X to the 8th divided by x squared is going to be x to the 6th power. You subtract these. And then minus 3, because 6 divided by 2 is 3. And the x squares cancel each other out. So this is the final answer. Okay, how about number 11? 20 is not a perfect square, so this does not fit the difference of squares pattern. However, there is a common factor, so let's do the GCF. Okay, the second term has no variable, so that means there will be no variable in the GCF. But what about the number part? Well, 20. Both of these are divisible by 20. So that means 20 is going to be my GCF. And I need to divide everything by 20 to figure out what goes inside the parentheses. So in this case, the 20s are going to cancel each other out, and that's just going to leave x squared. 100 divided by 20 is 5. So this is going to be the final answer. Okay, look at problem number 12. This definitely does not fit the difference of squares pattern. All right, it has 3 terms for one thing. However, there is a GCF. So, do all of the terms have variables? No, the 18 has no variables. So, no variable in the GCF. But they are all divisible by 3. So, 3 is going to be my GCF. Okay, so look, to figure out what goes inside the parentheses, I need to divide everything by my GCF. So these 3's are going to cancel each other out, and that's going to leave x squared. 12 divided by 3 is 4, so this will leave 4x. And 18 divided by 3 is 6. So this is going to be the final answer. Number 13 does fit the pattern of the difference of 2 squares. So let's go ahead and break it down. 25, of course, is 5 times 5. X to the 6th power would be x to the 3rd power times x to the 3rd power. And it'll be one of them will be plus and one minus. And then 49 is 7 times 7. So taking a look at number 14. Well, this has neither a GCF nor is it the difference of 2 squares. So this is going to be prime. All right, there's nothing that divides into 36 and 25. All of the terms don't have x's, and this is a plus, so it's not the difference of 2 squares. If this were a minus, then I could do 6x plus 5, 6x minus 5, but not a plus. Okay, how about this one? Well, it's not the difference of 2 squares because it's got 3 terms. Is there a GCF? Well, I'm noticing that all of these are divisible by 2. So if I were to divide everything by 2, that would give me 6x squared plus 3x minus 5. Okay, so there is a GCF, and this will be the final answer. This is the difference of 2 squares. Let's go ahead and see why. 9 is 3 times 3. X squared, of course, is x times x. And now I'm going to have 1 plus and 1 minus. 121 happens to be 11 times 11. So 121 is 11 squared. So this is the final answer for number 16. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.